3, the tutorial 2 video. In this tutorial, it won't be as long in video-wise. In the actual tutorial, I'll have a lot more discussion with people for the questions and answering anything extra that comes along there. But again, like I said, every tutorial, I want you guys to be moving forwards and completing more of the actual assignment. And so by this tutorial, we should have at least started or finished getting through the majority of the algorithm analysis notes, which is the last notes that you need to actually complete this actual overall task. So in this quick video, I am just going to go through the questions and first key into some of the things that we should have been taught this week, or maybe it'll be taught when we finish off algorithms analysis after the tutorial. It depends upon the timing, how everything goes in class. But you can also go ahead and watch the complete algorithm analysis video and get ahead on the assignment if you want. So question 1, as I've mentioned before, is what is an ADT and why is it useful in relation to data structures and programming? The information for that is in that intro lectures, that like intro to what is data structures and what is this abstract data type and how does that relate to data structures and programming and why do we need that? Question 2, and really the rest of the questions in here relate to algorithm analysis. So question 2 is 1 mark. You don't need to write a lot. This should be point form, basic steps. To answer this question is, what are the steps required to determine the big O of a growth function? And you're here now, so I'll just give it to you. Remember that you have to find the dominant, so you take the growth function for the algorithm that you've been given, you find the dominant term out of all of them, where you can use that chart. And so even if I bring up this chart, you can see here, like we've seen before, is you're looking through all the actual terms themselves for the growth functions, and then you're looking for which one's most dominant. And this chart can help by, again, up here are more dominant than the ones below, and same, these are like the ones that are going more to the left and spiking up faster are your more dominant ones that you're working with. So again, what are the steps required to determine the big O of a growth function? So first, look at all the terms, find which one is dominant, drop all other terms in that one, and any constants, so like numbers and stuff that you see in front of that term, you drop that, and that's the order of it. And then next, you must include the step for full marks in this question as well, is that to write it out, you must go a big O, open round bracket, the order that you found and closing round bracket. So things like O, big O of n. So you see the big O, opening curly bracket, or open round bracket, then n squared, then closing round bracket, to have proper notation right here. What does the term asymptotic complexity mean in relation to analysis of algorithms, and why should we care? Remember, this is as your data grows bigger, how do things get more complex for your algorithm? And for us, this is in more relation to the time complexity. So as your data and complexity increases, how much longer does your algorithm actually take to execute? And like, why should we care? Efficiency. Efficiency of your programs, and it's smaller data sets, you don't notice it. When it goes larger and it takes forever to run, that's time and everything for programs. And if you're able to write an algorithm that executes faster than another one, then yours is better. That's the better one to use. You're saving computational cycles, you're speeding up the overall entire program, and whoever's actually using it in the end, it makes a massive difference. And in our modern day, when there's tons and tons of data going all the friggin' time, you want to make sure that, like, if you can, to make it as efficiently as you possibly can. So that's why we're taking a look at this for algorithms. The next 4, 5, and 6 are just very basic ones. You have to determine the big O for each of these growth functions. And just remember, this little hat symbol you're seeing here is just supposed to represent exponential. So you have the 45, this is 45n squared, so that means n raised to the power 2. And this is just, I wanted to make it easy to read when in the form and other stuff where you can't have like fancy formatting. So ignore it from here. So here you just have to give the order. You don't have to show me the steps or anything else you went through. And we knew the steps before, we're just listed up here. And so you just have to remember, you look through this entire thing to first define it. You then look through each term. So we have one term here, you have another term here, and another term here. And you're trying to find out which one is dominant. And if you're not sure, then you just bring up the chart again that you can find in the slides, and you want to compare to each one and see, well, what's happening. And so we'll just take the first one here, example. That I'll start from the backwards here because it's kind of easy to see which one's going to grow dominant. But I have 6n squared. So if I look up here in the chart, okay, I got n squared here, kind of mid-range. So far this is the dominant term I know. Next I've got n log n. Okay, n log n, and this chart is below n squared. So this means that, okay, that's not the dominant term. So out of these two, this is the dominant term, and then finally add the third one, which here is 45 n squared log n. And we can see we don't have an n squared log n on this chart, but the idea is you kind of combine it together. So we got n squared and we got n squared, so we should be right here. And this is n squared times by something, so that's going to cause it to go higher. And this is log n, and there's nothing else comparing. So this is like some factor that's going to grow larger as we go here, and it will not take it lower. So you should have n log n. That will go larger from these ones than the actual like n squared. And that's mainly because we have n squared here for stuff going above. And you can see an example here. If we're looking like you have log n below, we have n, but n log n is more than n because you're timesing this extra by here, which will throw it into a new classification. So if we're looking at this first one, you have to remember that this is then the dominant term from that. The next step is drop any constants. You drop the 45, so it should be n squared log n, and you can use this little hat symbol just to represent that you have the exponential when you're doing it. So this is the actual order, so not the 45 but the n squared log n. And when you send it to me in the form, I want to see the O round bracket n squared log n closing round bracket for proper big O notation. Without that, I'll take off some marks from this. So the rest of these, you just want to go through doing the same thing. Look for which is the the dominant term. Drop any constants, do in the order. Same as this. So these are all quick, short ones that you can do at this time. And I suggest if you're listening to this tutorial, go answer these questions. If you've gone through the asymptotic notes, you should go answer these and get these done right now. So you need to explain your steps. You just need to give the big order. The next thing you need to do is for question 7 and question 8 is actually just give the actual growth functions for these and the big O. So give the growth function and the big O for the code. Show all your work in both steps. So you can do this in a document and then you can upload a PDF or a picture of it. You can do this on paper with your handwriting uploading it. And the idea is show me your work so it makes it clear that you're showing that you understand what you're doing. And so I suggest that you kind of figure out the time complexity of individual elements from right here and then going overall what you have, and then make sure you're getting the right big O once you have the growth function. I'll give some quick guidance right now. Since you're in the function, you don't need to do anything for the headers for the function. You're just doing this code that's internally inside of here, so that you see here. So that this code right here is what you are converting. You have to remember first is break it into segments. So these are two independent segments. This is then another segment, and I'm making it a segment because this is a loop and all this code has to run inside this loop. So we know we have the time complexity of this plus the time complexity of this. This is your basic kind of command rule you want to find, that each one of these would be 1. So that's 1 and plus 1. So this overall case would be 2. And then next for this one is you have the loops. So you remember you figure out the actual complexity of the inside of this and you times it by the number of iterations of the loop. This one you should be able to do quickly. 2 basic operations, separate lines. So that's 1, that's 1. So the internal is 2 here. This then is your end minus your start. So n minus 0. And then here we're going up by 2 as the actual increment. So it's n minus 0 over 2. And then that n minus 0 is just n, and then you're dividing it by 2, so this is 1/2 n, and you're timesing it by 2. That's right in here. And so the ironic thing, this is 2 times by 1/2 n, so this just becomes n, because the 2 in here times by a half just cancels out because you get 1. So you're basically getting n plus 2 for this entire function. So hey, look, if you're watching this video actually going through tutorials, I gave you the answer to this question, but now you got to show me the steps and take your practice, because you can expect on future tasks and on the midterm and for the final you could get questions like this. So it's good to practice now. You can go and figure out the big O for this, but seriously, it's n plus 2. It's really fast to figure out what the big O of that growth function is. The next one is a little bit more, just combining here that you got segments again. So you have one segment there, You have another segment here for the loop. And then next we have the if else. And the idea is I'm going to group all of this together because you have an if, and this else only is connected to this if. If it was one if, then another if, then another if, that's completely different because this if has to execute. Whereas this if else is this code may execute or this may code execute, so you go through it. The next steps to remember for the conditional rule is first figure out the time complexity for the conditional. Here there's no function call, so this is just 1. Next you figure out the time complexity for this segment, then time complexity for this segment. Then you look and compare which one would grow faster. Whichever one grows faster, you pick that one. And then that goes that value plus this, and then that you figure out here, and then you add it to this time complexity, and you add it to this time complexity, get your growth function, and then get your big O from there, clearly showing all your work, clearly showing all the proper documentation. So nothing that's too bad. In the tutorial, I'll probably try to do this live with people where we figure it out and people talk and make sure that they understand it from the steps from right here. You right now should sit down and do it yourself if you're doing this at home without being at the tutorial. And then the last question, well, we've already covered this in the first tutorial thing, is the larger, which is really large but small coding project. But remember, when you're working on this, don't just do this program. Go back and keep reviewing your Java 2 notes. Go back, look at your assignments, your skills, and try taking on maybe some previous assignments and like thinking, how would I code that? How would I deal with that? Because we're going to be ramping up in the coding as we go, and the semester is going to be faster, and we can't keep reviewing everything from the previous courses again. Okay, from there, please feel free to contact me if you have questions. I suggest you go back and answer these questions and get this task done as soon as possible. It may be due October 1st, but I'd suggest get it done before then because you're going to have other stuff due in other courses already and other tests coming up. And so it's better to get this done out of the way so you don't have to worry about it, and then you can get your mark back faster and generally just feel better. Other than that, this may be a quick 12-minute video for the tutorial, but this is where I said in the tutorial I'm going to have a lot more discussion going on. I will also help with anything that's with the coding questions from the previous tutorial that may not be comfortable in answering questions from here. And I'll be going through where we try to answer these questions a little bit slower and get people to come together of like, well, what does these mean? How would you answer it? And same thing for doing this work, and then the same thing for doing like this work and getting it up on the board and getting students to do it and taking that time to learn those steps. So if you're at home doing this on your own, take the time just to sit back and like work through this and get it done quicker. Other than that, as I say, always remember you're awesome, and never forget that I will disagree with you if you think you're not awesome, because you are. And if you can, make sure to take care of yourself and take care of those and the people around you. Even if they're small actions, it can make a big difference for just the general happiness of people in this world right now.